Stop scrolling right now because what I'm about to tell you contradicts the narrative. You've been hearing from critics of American armor for the past 3 decades. There's a story that's been circulating in defense circles, propagated through leaked documents and second-hand accounts, claiming that American tank armor failed catastrophically during classified NATO testing in the late 80s. That story is incomplete, deliberately misleading, and ignores the single most important engagement that proved American armor wasn't just adequate, it was revolutionary. February 26, 1991. A date most people don't remember but every armor officer in the US military knows by heart. The Battle of 73 Easting in Iraq, where American M1A1 Abrams tanks equipped with a depleted uranium armor package engaged Iraqi T-72 tanks in conditions that should have been a nightmare scenario for armor protection. Close range, limited visibility, surprise engagement, everything that negates standoff advantage. That Abrams didn't just survive, they dominated in a way that fundamentally changed how the world understood armored warfare. But here's what almost nobody talks about and what the critics deliberately avoid mentioning. Multiple Abrams tanks took direct hits from T-7 to main gun rounds, 125mm armor-piercing ammunition specifically designed to defeat NATO armor, and those rounds did not penetrate. Not because the Iraqis were incompetent, though their tactics were poor, not because they were using degraded ammunition, though some of it was older stock, but because American armor, when actually tested under real combat conditions against real threat weapons, performed exactly as designed and better than the pessimistic assessments suggested it would. By the end of this investigation, you're going to understand why American tank armor represents one of the most successful materials engineering achievements in military history. And more importantly, why the people who want you to believe it's inadequate have agendas that have nothing to do with honest technical assessment. Let me start by addressing the elephant in the room. The 1987 test at Grafenwohr that I know many of you have heard about through other sources. Yes, that test happened. Yes, certain ammunition achieved penetrations that were concerning. But here's what gets left out of every sensationalized retelling of that story. The armor that was tested in 1987 was the original M1 composite array, not the M1A1 heavy armor configuration with depleted uranium that was specifically developed in response to emerging threat assessments. The testing revealed vulnerabilities in the original design. The vulnerabilities were addressed through material science improvements, and the upgraded armor was fielded before the first major combat test in Desert Storm. This is how engineering is supposed to work. You test, you find problems, you fix problems, you test again. The fact that early testing revealed areas for improvement isn't a scandal. It's proof that the testing system was actually working. But let's focus on what happened when American armor faced real combat, because that's the only test that ultimately matters. The Battle of 73 Easting took place during the ground war phase of Desert Storm, when the 2nd Armored Cavalry Regiment and elements of the 1st Infantry Division engaged the Tawakalna Division of the Iraqi Republican Guard in what became the largest tank battle since World War II, where the conditions were terrible. A sandstorm was reducing visibility to less than 1,000 meters, which meant that the Abrams couldn't leverage its superior optics and fire control at extended range. Engagement distances were compressed to 800 meters or less in many cases, well within the effective range of Iraqi T-72 main guns. The Iraqi tanks were dug into prepared defensive positions, hull down, with only their turrets exposed, which is the tactically optimal position for tank defense. They had the advantage of surprise because American forces didn't know exactly where the Republican Guard positions were until they drove into them. And critically, the Iraqis were equipped with the best ammunition in their inventory, including 3 BM-15 and 3 BM-42 armor-piercing rounds that Soviet doctrine specifically designed to defeat NATO composite armor. This wasn't some one-sided turkey shoot against incompetent third-world conscripts. This was a mechanized force with decent equipment in good defensive positions engaging American armor under conditions that negated many of America's technological advantages. So what happened? In approximately 3 hours of combat, American forces destroyed approximately 160 Iraqi armored vehicles, including T-72 tanks, BMP infantry fighting vehicles, and various support vehicles. American losses were 0, Abrams tanks destroyed, 0 crew fatalities from enemy fire on Abrams platforms. But here's the critical detail that proves armor effectiveness. At least 9 Abrams tanks took direct hits from Iraqi main gun rounds during the engagement. These weren't glancing blows or hits on external equipment. These were direct impacts on the armor from 125mm. Armor-piercing ammunition at ranges where kinetic energy is at maximum effectiveness. Tank Calcine Cobra II, an M1A1 heavy armor variant, took a direct frontal turret hit from a T-72 firing a 3BM-42 round at approximately 900 meters. The round impacted the composite array, created a significant divot and stress fracturing, and did not penetrate. The crew reported a massive impact, brief disorientation from the shock, and then continued engaging targets. Post-battle inspection showed that the armor had performed exactly as designed. The ceramic strike face shattered the penetrator. The backing layers absorbed the remaining energy. and the depleted uranium mesh ensured that no spalling or fragmentation entered the crew compartment. The tank required armor replacement but was operationally returned to service within weeks. Tank Alcine Bandit 6 took 2 hits in rapid succession, one on the frontal hull and one on the turret side. Both rounds were from T-72s at ranges estimated between 700 and 800 meters. Neither penetrated. The crew continued fighting and destroyed both attacking vehicles. Post-battle analysis showed that even the side turret armor, which is thinner than frontal protection, was sufficient to defeat the Iraqi penetrators at combat ranges. This directly contradicts the narrative that side armor is vulnerable to main gun fire, at least when we're talking about the M1A1 heavy armor. Configuration with depleted uranium. Now, let's talk about why the armor held when critics claimed it shouldn't. Because this is where materials science and engineering design demonstrate why American armor was genuinely revolutionary. The depleted uranium mesh layer that was incorporated into the M1A1 heavy armor isn't just dense material added for mass. Depleted uranium has a property called adiabatic shear banding that makes it uniquely effective against kinetic penetration. When a tungsten or steel penetrator impacts depleted uranium at high velocity, the uranium doesn't just resist penetration through hardness like steel does, it actually self-sharpens and fragments the incoming penetrator through localized phase transformation at the impact point. Here's what that means in practical terms. A tungsten penetrator hitting rolled homogeneous steel armor will either punch through if it has sufficient energy, or it will mushroom and stop if it doesn't. It's a relatively predictable interaction, but a tungsten penetrator hitting depleted uranium undergoes something much more complex. The impact creates intense localized heating at the interface between the penetrator and the uranium. This heating causes the uranium to undergo a phase change that creates microscopic fractures in the penetrator. As the penetrator tries to continue through the armor, it's being fractured and fragmented by the uranium layer, which dramatically reduces its ability to maintain coherence and continue penetrating through the backing layers. This isn't theoretical physics. This is documented materials science that's been studied extensively in unclassified literature. The Soviet penetrator designs that were optimized for defeating steel and ceramic composite arrays were not optimized for this interaction with depleted uranium. They were designed assuming that if they could get through the ceramic strike face with sufficient energy remaining, they would penetrate the backing steel. But the depleted uranium layer changed that calculation entirely. Even if a penetrator maintained coherence through the ceramic, the uranium layer would fragment it before it could reach the final backing plate. The Battle of 73. Easting proved this under real combat conditions. Iraqi penetrators that should have been capable of defeating the armor based on their performance against test targets without depleted uranium failed to penetrate when they encountered the actual fielded armor with the uranium layer. This is why the 9 documented hits during that battle resulted in 0 penetrations and 0 casualties. The armor wasn't lucky, it was engineered correctly. But let's address the obvious counter-argument, because I know exactly what the skeptics are thinking. The Iraqi ammunition was degraded. The Iraqi crews were poorly trained. The engagement conditions favored the Americans despite the sandstorm. Let me walk through why each of these objections doesn't hold up under scrutiny. First, ammunition quality. Post-war analysis of captured Iraqi ammunition stocks included metallurgical examination of the penetrator. The 3BM42 rounds that were recovered were manufactured in the Soviet Union in the mid to late 80s and were within specification for penetrator hardness, dimensional accuracy, and propellant performance. These weren't decayed rounds that had been sitting in the desert for decades. They were relatively recent production that matched Soviet military standards. If these rounds couldn't penetrate Abrams' armor, it's because the armor was effective, not because the ammunition was defective. Second, crew training. Yes, Iraqi tank crews were generally less well trained than American crews. And yes, Iraqi tactics during Desert Storm were frequently poor. But hitting a target at 800 meters with a stabilized main gun is not a difficult task, even with minimal training. The Iraqis achieved hits on American vehicles. We know this because we have the battle damage to prove it. The issue wasn't that they couldn't hit American tanks. It's that when they hit American tanks, the armor didn't fail. Crew quality affects your ability to acquire targets, to make good tactical decisions, to employ combined arms effectively. It doesn't affect whether your ammunition penetrates armor once you've achieved a hit. Third, engagement conditions. The sandstorm that reduced visibility actually worked against the American advantage in long-range optics and fire control. American doctrine for employing the Abrams is based on engaging at 2,000 meters or more, where the thermal sights and fire control computer give overwhelming first-shot hit probability. At 800 meters in a sandstorm, you're much closer to neutral conditions where both sides can acquire and engage targets. The fact that American armor still dominated under these compressed engagement ranges is evidence that the protection was robust, not that the battle was somehow unfair. Now, let's talk about what happened after Desert Storm, because the combat performance data from that conflict fundamentally changed how the world understood armor protection. The U.S. Army conducted extensive post-battle analysis, including detailed examination of every Abrams that took a hit. The armor samples from the 9 tanks that were struck by enemy fire were removed, sectioned, and analyzed to understand exactly how they had performed. The findings were classified in their specifics, but the general conclusions were documented in unclassified lessons learned reports. The depleted uranium armor had exceeded performance expectations. In every case where a hit was recorded, the armor had contained the penetration with no crew injuries from primary penetration or secondary fragmentation. This data was used to validate the armor models and to inform the next generation of armor development for the M1A2 variant. But more importantly, it was shared with NATO allies as proof that American armor technology was legitimate. Remember that skepticism from Germany about Abrams protection that I discussed in previous investigations. That skepticism largely evaporated after Desert Storm because the combat data was undeniable. German observers who analyzed the battle damage on American tanks that had been hit acknowledged that the performance was extraordinary and that that represented a genuine technological advantage over existing European designs. The Soviet response to Desert Storm armor performance is equally telling. Within 2 years, Soviet and then Russian armor development programs had completely shifted focus to developing penetrators specifically designed to defeat depleted uranium-enhanced armor. The development of longer, higher-density penetrators with improved sectional density was a direct response to the realization that their existing ammunition was inadequate against this specific armor configuration. You don't invest heavily in new penetrator development unless you've acknowledged that your existing ammunition has a serious problem. Chinese armor development followed a similar trajectory. In the mid-90s, Chinese technical literature began discussing the importance of depleted uranium in armor arrays and the challenges it posed for penetrator design. This wasn't abstract theorizing. This was the Chinese defense establishment recognizing that American armor represented a capability gap that needed to be addressed. Again, you don't shift your entire armor technology development roadmap unless you've accepted that the opposing technology is genuinely effective. So, why does this narrative persist that American armor is somehow inadequate or that it's been defeated in testing? I can identify 3 reasons, and understanding them explains a lot about how defense technology gets discussed in public. First, there are legitimate classified test results that showed vulnerabilities in specific armor configurations. Under specific conditions, those results get leaked, usually in fragmentary form, and then get generalized to suggest that all American armor is vulnerable under all conditions. The 1987 Grafenwohr test is a perfect example. That test identified issues with the original M1 armor against certain ammunition. Those issues were fixed in the M1A1 heavy armor, but the leaked information about the test never includes the context that the vulnerabilities were in an older configuration that's no longer fielded. Second, there's institutional bias within the defense industry and military bureaucracies toward emphasizing threats and vulnerabilities because that justifies continued funding for upgrades and new development. If you're trying to get funding for the next generation of armor, you have an incentive to emphasize that current armor has limitations. This isn't necessarily dishonest. Armor technology and anti-armor technology are in constant evolution, but it creates a bias toward highlighting problems rather than successes. The result is that successful armor performance like 73 Easting gets less attention than concerning test results like Grafenwohr, even though the combat performance is ultimately more important than controlled testing. Third, and this is the most cynical but probably most accurate reason, there are foreign competitors who benefit from undermining confidence in American armor. If you're trying to sell Leopard 2 tanks or Leclerc tanks or Challenger tanks, you have an incentive to spread doubt about Abrams' effectiveness. This doesn't mean the competitors are lying, but it means they're going to emphasize data that makes their products look good and American products look questionable. The result is a discourse where American armor failures, real or exaggerated, get amplified while American armor successes get minimized or ignored. Let me be absolutely clear about what I'm arguing here, because I don't want to be accused of jingoistic cheerleading for American equipment. I'm not claiming American armor is perfect or invulnerable. I'm not claiming it can defeat every possible threat under every possible condition. What I'm claiming is that American armor, specifically the M1A1 heavy armor configuration with depleted uranium, performed extraordinarily well under the only test that ultimately matters, which is real combat against real threats. The 9 tanks that took hits at 73 Easting are proof that the armor works as designed when it's actually needed. I'm also claiming that the narrative emphasizing American armor vulnerabilities is selectively using data to create a misleading impression. Yes, certain tests under certain conditions have shown but combat experience under realistic conditions has shown successful protection. When those 2 sources of evidence conflict, combat experience should be weighted more heavily than controlled testing, because combat includes all the variables that controlled testing struggles to replicate. Here's what the armor technology tells us about American materials engineering more broadly. The development of the depleted uranium armor package wasn't just about adding dense material. It required understanding the physics of how kinetic penetrators interact with different materials at microscopic scales. It required manufacturing processes that could bond uranium to steel and ceramic in ways that maintained structural integrity under extreme shock loading. It required extensive testing to validate that the theoretical advantages of uranium would actually manifest in real armor arrays, and it required the institutional willingness to invest in expensive, controversial materials when simpler, cheaper alternatives were available. The fact that this investment paid off in combat is evidence that American defense R&D, whatever its flaws in other areas, got armor development right. The depleted uranium package represents a genuine technological advantage that adversaries have spent 3 decades trying to counter. The continued use of depleted uranium in current Abrams variants, despite ongoing health and environmental controversies, is evidence that military planners consider it essential for protection. You don't stick with controversial materials unless they provide capabilities you can't get any other way. Let me address one final point because I know it's going to come up in the comments. What about future threats? What about newer Russian penetrators or Chinese armor-piercing ammunition that's been developed specifically to defeat depleted uranium? This is a legitimate concern, and it's why armor development is ongoing. The M1A2 CP3 includes armor improvements that are classified but are understood to address emerging threats. But here's the critical point. The fact that armor needs to evolve to address new threats doesn't mean current armor is inadequate. It means armor and anti-armor are in constant competition, which has been true since the first tank rolled onto a battlefield. The question isn't whether American armor can defeat every possible future threat. That's an impossible standard. The question is whether American armor provides effective protection against current and near-term threats, and whether the development process is responsive enough to address emerging capabilities before they become widespread.